problem. Let X be the R vector space. Of all twice differentiable functions. Twice differentiable real valued functions defined on the interval 0 open close interval 0 to 1, and consider the linear map pi from X to R cube defined by pi of f equal to f of 1, f dash of 1, f prime of 1, and f double prime of 1. So this one is order triple, which belongs to R cube. Then which one of the following is true? Which one of the following is true? Options are the dimension of x by k pi is equal to 3, and option B, the k pi is finite dimensional, and option C, the dimension of x by k pi is equal to 1, and option D, capital X is finite dimensional. Capital X is finite dimensional. So ichina question enti X is the set of all functions, real vector space of all twice differentiable real valued functions are defined on closed interval 0 to 1. So therefore here X equal to set of all twice differentiable functions, right? Twice differentiable functions. So therefore this one is an infinite dimensional space, right sir? Enduku B is equal to sin x, sin 2x, sin 3x up to so on. Which one forms a basis? ఇలా కాకుండా ఇంకా infinite number of bases exist అవుతాయి. So forms a basis for the x, since sin x, sin 2x, sin 3x are all twice differentiable functions. In fact, it is infinite differentiable functions. So therefore, the dimension of x is equal to infinity, sir. So therefore, the space x is infinite dimensional space. So option D is false, and option D is also false. And now we need to check the linear map pi from x to r cube defined as pi of f equal to f of 1, f dash of 1, and f double dash of 1 kada. So now assume that pi from x to r cube such that pi of f equal to f of 1, f dash of 1, f double dash of 1. F double dash of 1 is a linear map. It's a linear map. Suppose assume that f1 is equal to 1, f2 is equal to x, and f3 is equal to x square. All are twice differentiable functions, so it belongs to x only, right? So now find the images of all these one. Pi of f1 is equal to differentiation of 1 is f of 1, sir. F of 1 is 1, f dash of 1 is 0, and f double dash of 1 is also 0, and pi of f2. So f2 of 1 ante substitute x equal to 1, and differentiation of x is 1, sir. So double derivative of f2 is 0, and pi of f3, which is equal to Substitute x equal to 1 here, then you will get f of 1. And differentiation of f3 is 2x, 2 into 1 is 2. And f double dash is equal to 2, sir. So a value the same constant. So therefore these three vectors which are belongs to the image of pi, right? Image of pi. So therefore 1 0 0 1 1 0 and 1 2 2 forms here Li set, linear independent subset of R cube, image of pi, right sir? Enduku date find out cheyandi 1 0 0 1 1 0 1 2 2 sir. Date enta 1 into 1 into 2 kada, which is equal to 2, which is non-zero. So this is linearly independent and spans image of pi, sir. So that means if the dimension of image of pi is equal to 3, sir. So but the codomain is R cube, sir. So that means which is equal to dimension of R cube. So therefore image of pi is equal to R cube, sir. Image of pi is equal to R cube. Dimension of x by k pi. So by rank nullity theorem, rank nullity dimension of the domain is equal to dimension of k pi plus the dimension of image of pi, sir. So therefore, but dimension of x is equal to infinity, sir, which is equal to dimension of k pi plus dimension of image of pi is equal to 3, sir. So therefore this should be is equal to infinity cover. So the dimension of k pi should be infinity, sir. So therefore k pi is finite dimension, so this is also wrong. Now we need to find dimension of x by k pi. So therefore dimension of x by k pi ante enta. So by fundamental theorem, x by k pi is isomorphic to image of pi kada. X by k pi is isomorphic to image of pi, where image of pi is isomorphic to R cube. Ikkada R cube, since the pi is onto here, pi is onto kabatti image of pi is equal to R cube. So therefore the dimension of x by k pi is equal to dimension of image of pi, sir. But the dimension of image of pi is equal to 3, sir. So therefore option A is true, sir. And option A is true kabatti option C is false. So the correct answer is A, sir. Yes, sir. Next one, same linear algebra question. So which one of the following are similar to the matrix A? The matrix A is equal to -1 1 0 0 0 -1 0 0 0 0 1 1 0 0 0 1 over R. The given options are option A 0 0 -1, sorry 0 0 0 -1, 1 0 0 0 0 1 0 2 0 0 1 0, and option B 0 0 0 1 1 0 0 0 and 0 1 0 -2 1 0 1 0, and option C 0 1 0 0 1 0 0 0 0 0 0 1 and 0 0 1 0, and option D is 0 1 1 0 1 0 0 1 and 0 0 0 1 and 0 0 1 0. సో ఏమి ఇచ్చాడు? ఏ అనే మ్యాట్రిక్స్ ఇచ్చింది ఓవరాల్లో. సో దానికి సిమిలర్ మ్యాట్రిక్స్ ఫైండ్ అవుట్ చేయమంటారు. So what is A, sir? What is A here? So this is black matrix, right? Black matrix. And also check the Jordan black kada. Jordan black of 2 by 2 Jordan blacks. This minus 1 key, this plus 1 key, sir. So this is J2 of minus 1, J2 of 1, sir. Jordan blacks of 2 by 2 matrices. So A అనేది already Jordan black లో ఉంది. So therefore దీని యొక్క characteristic polynomial ఏంటి, sir? A minimal polynomial ఏంటి? By using the Jordan block. So lambda plus 1 whole square kada. Lambda plus 1 whole square into lambda minus 1 whole square. Minimal polynomial and also characteristic polynomial. So which is equal to lambda square minus 1 whole square, which is equal to lambda square minus 2 lambda plus 1. So therefore minimal polynomial contains non-linear factors, so it is not diagonalizable, right? It is not diagonalizable. So the given matrix is not diagonalizable and the eigenvalues are plus or minus 1 plus or minus 1 or 1 1 minus 1 minus 1. So similar matrix ki same Jordan form undali, same eigenvalues, characteristic equation, whether it is diagonalizable aithe diagonalizable kavali, kakapothe then it is not diagonalizable kavali. So for option A ఏంటి సార్? 0 0 0 minus 1 1 0 0 0 0 1 0 0 2 0 0 1 0 కదా. So it is a companion matrix, right? Companion matrix. And also option B is also companion matrix andi. So e coefficients non-zero, ఇది identity, ఇది 0. Companion matrix. So if 0 0 0 minus A1, 1 0 0 minus A2, 0 1 0 minus A3 and 0, sorry, ఇది A0, ఇది A1, ఇది A2, 0 0 1 minus A3 and అనుకోండి, then it is called a companion matrix and the minimal polynomial of this part. And characteristic polynomial and minimal polynomial both are same for this companion matrix, and which is equal to x power 4, which is a 4 by 4 matrix. X power 4 plus A3 into x cube plus A2 into x square plus A1x plus A0. Okay, now compare with this option A. So therefore the minimal polynomial of A and the characteristic polynomial of A is equal to ఏమవుతుంది? x power 4 ఇక్కడ A3 ఏముంది సార్? A3 is equal to 0, right? A3 is 0 అంటే 0 into x cube is 0 plus ఇక్కడ ఏముంది minus plus 2 ఉంది, that means minus 2 x square plus minus 1 అంటే minus of minus is plus 1. So which is the characteristic equation and also minimal polynomials. So which is nothing but x square minus 1 whole square actually, which is equal to same eigenvalues and eigenvalues are plus or minus 1 plus or minus 1. So minimal polynomial ide, characteristic polynomial x square minus 1 whole square both are same ante dani yokka Jordan block enti sir? Same minus 1 1 0 minus 1 0 0 0 0 0 0 1 1 0 0 0 1. The minimal polynomial x square minus 1 whole square, so which is also, so therefore it is also not diagonalizable, so it is similar to A. Option A is true. Option A is true, sir. What about option B? Option B is equal to, so minimal polynomial, sir. So A3 0, A2 is minus 2, and x power 4 plus 0 minus into and plus 2x square minus 1. So x power 4 plus 2x square minus 1. So the minimal polynomial of option B is not equal to minimal polynomial of A, sir. So therefore, this is not similar matrix, right? And what about C, sir? So this is black matrix, right? So eigenvalues of this one equal to lambda, minimal polynomial of this one is lambda square minus 1, right? And this one is lambda square minus 1. So which is equal to lambda square minus 1 whole square. So which is equal to lambda power 4 minus 2 lambda square plus 1. But the minimal polynomial, the characteristic polynomial of option C and given matrix is same. But observe that the option C is symmetric matrix and 0 1 0 0 1 0 0 0. So therefore, assume that this is C. So which implies C is equal to C transpose, and it is real symmetric matrix. So every real symmetric matrix is diagonalizable, right? But the given matrix is not diagonalizable, so it is not similar to A. It is not similar to A. What about this? This one is also black matrix. So what is the characteristic equation, sir? So characteristic equation of C, D and so CD of X is equal to same, sir. Lambda square minus 1, lambda square minus 1, which is equal to lambda power 4 minus 2 lambda square plus 1. So same undi, but it is diagonalizable avutunda leda check cheyali. So find A minus lambda. So geometric multiplicity of plus or minus 1 kada eigenvalues. Plus 1 find out cheyandi A plus I. A plus I cheste em vastundi sir? A plus I. 1 1 1 1 1 0. Next 1 1 0 1, right? 1 1 0 1. Next 0 0 1 1 and 0 0 1 1. Substitute lambda is equal to A plus I, sir. I add చేస్తున్నాను D కి. So therefore ఇది D అన్నాం కదా. So D. So into X and so find the, so therefore the geometric multiplicity of minus 1 is equal to number of zeros in D plus I. Reduced echelon form convert cheyandi, then number of zeros in unnayi find out. So number of zeros in untayi echelon form lo convert chestam. So 1 1 1 0 and R2 minus R1 cheyandi. So 0 0 minus 1 minus 1. Next 0 0 1 1 0 0 1 1. Next 1 1 1 0 0 0 minus 1 minus 1 0 0 0 0 0 0 0 0. Antena? So number of 0 rows is equal to 3. ఇది ఎక్కడ మిస్ అయింది. -1 + 1 కదా ఇది, రైట్ సార్. 0 0 R2 minus R1, సో +1 సార్. సో ఇది +1 కాబట్టి -1 + 1 అంటే ఇది 4th one is 0, ఇది 0, ఇది 1, 2 వస్తుంది. సో therefore number of 0 rows is equal to 1. So therefore the geometric multiplicity of minus 1 is 1. So కానీ దీని యొక్క algebraic multiplicity ఎంత సార్ +1. So therefore algebraic multiplicity of minus 1 is not equal to geometric multiplicity of minus 1, sir. So it is not diagonalizable. So therefore option D is also true. So it is similar to matrix CS. So both A and D are true. Both A and D are similar to the matrix A. Maybe the 4.75 marks వచ్చినట్టుంది. Next one. Topology నుంచి వచ్చిన సార్ క్వశ్చన్ ఇది. Let S is equal to 1, 2, 3, 4, 5. The set will be equipped with the topology tau is equal to empty set, singleton 1 and yes. Then the number of homeomorphisms from S unto itself. S unto itself is another. Options are 25. Option B is 120. Option C is 24. Option D is 6. Option D is 6. Oh, what is homeomorphism, sir? So ఇక్కడ topology ఏంది? Tau is equal to empty set 1 whole space x. So ఏదైనా ఒక ఎలిమెంట్ tau లో ఉన్నది అనుకోండి, then those are called two open sets or open sets అంట. So all these are open sets అండి, right? What is homeomorphism, sir? Homeomorphism means if any set from S to S is said to be homeomorphism, then it is both bijective, that is 1, 1 and on 2, bijective, and F comma F inverse are continuous. F and F inverse are continuous. In other words, if F is continuous and also it satisfies the open mappings, F S to S is bijective కావాలి, F అనేది continuous కావాలి, F satisfies the open mapping. If you take any open set in a domain, then F of G is also open in its codomains. అయితే then it is called an homeomorphism. Okay. So suppose assume that let F S to S is homeomorphism. F S to S is a homomorphism. That means F is 1, 1 and on 2. 1, 1 and on 2. F and F inverse are continuous, right? And F is continuous and open mapping. F satisfy the open mapping. అంటే every open set in domain తీసుకుంటే కోడొమైన్ లో కూడా దాని యొక్క ఇమేజ్ open map open set అవుతుంది. If G is an open set in a domain, then F of G is also an open set in a codomain. That means the topology లో ఉండాలి సార్. So which contains tau. కానీ topology tau లో ఏమేమి ఉన్నాయి సార్? Pi, singleton 1 and S. So F satisfies the open mapping. That means F of pi is also an open set. So F of pi is equal to empty, and F of singleton 1 is equal to also. Suppose ఏదైనా ఒక set అనుకోండి, some x, and F of S is equal to whole space S is equal to S. But F of 1 కి choices ఉన్నాయి ఏంటివి? either pi కావచ్చు, singleton 1 కావచ్చు, whole space S కావచ్చు. కానీ F is bijective అన్నాడు. F is bijective 1, 1 and on 2. So F maps to a single element. So single element open set అయ్యేది only singleton 1. So that means f of 1 should map to 1, sir. So f of 1 should map to 1 ante f of 1 fix అయింది. So therefore homeomorphism కావాలంటే this is f s to s 1 2 3 4 5 1 2 3 4 5 1 to 1 మ్యాప్ ఫిక్స్ అయిపోయింది. రిమైనింగ్ ఎలాగైనా తీసుకోవచ్చు. సో 2 maps to 2 కావచ్చు, 2 maps to 3 కావచ్చు, 2 maps to 4, 2 maps to 5, 3 maps to 3 2, 3 maps to 3, 3 maps to 4, 3 maps to 5. సో ఎన్ని ఉన్నాయి చాయిసెస్? 4 ఎలిమెంట్స్ ఉన్నాయి. ఈ 4 ఎలిమెంట్స్ ఇంకో 4 ఎలిమెంట్స్కి ఎలాగైనా మ్యాప్ కావచ్చు. సో టోటల్ నెంబర్ ఆఫ్ బైజెక్టివ్ మ్యాప్స్ ఎన్ని ఎగ్జిస్ట్ అవుతాయి? ఫ్యాక్టోరియల్ 4. సో therefore there exist 24 homeomorphisms. So 1 ki matrame fix ayindi, remaining fix kaadu. So therefore there exist 24 homomorphisms. Next one. Suppose let y of x be the extremal of the functional. J of y is equal to integration of 0 to pi by 4 y dash square minus 4y square plus 2xy into dx, subject to the condition y of 0 is equal to 0, y of pi by 4 is equal to 1, then y of x is equal to dash. ఇది పార్ట్ బిలో వచ్చినచ్చు 1 minus pi by 4 into sin 2x minus xn. Option B 1 minus pi by 16 into sin 2x plus x by 4. And option C 1 plus pi by 4 into sin 2x minus xn. And option D 1 plus pi by 16 sin 2x minus x by 4. So what is the f here? F is equal to answer y dash square minus 4y square plus 2xy kada. So what is Euler's equation enti? Dou f by dou y minus d by dx of dou f by dou y dash equal to 0 kada. So what is dou f by? Differentiate f with respect to y partially. So dou f by dou y is equal to minus 8y plus 2x and dou f by dou y dash. So with respect to y dash only, so which is equal to 2y dash. Then substitute into in this equation, then you will get minus 8y plus 2x minus d by dx of 2y dash, which is equal to 0, sir. So which is equal to minus 8y plus 2x minus 2y double dash equal to 0. So take minus 2 common here, then you will get minus 2 common, this is y double dash plus 4y minus 2x equal to 0, sir. So that means y double dash plus 4y, which is equal to 2x. So what is an auxiliary equation? M square plus 4n equal to 0. M is equal to plus or minus 2i. So general solution is y is equal to c1 cos 2x plus c2 sin 2x only. So which is the complementary solution, and particular solution is 1 by d square plus 4 into 2x వచ్చిందా సార్? ఇక్కడ 2 కామన్ తీసినాం కదా. సో దిస్ ఈజ్ x అనుకో. సో therefore into xn. So therefore ఇది ఏంది? పాలినామియల్ కదా. సో టేక్ 1 by 4 కామన్, which is equal to 1 plus d square by 4 whole inverse into xn. So 1 by 4 into 1 minus d square by 4 plus dash dash into x. So 1 by 4 into local multiplication x minus d square of x and 0. So which is equal to x by 4. Right, sir? And the given boundary conditions are y of 0 is equal to 0 and y of pi by 4 is equal to 1, sir. Substitute x equal to 0 here, then you will get 0 is equal to c1 cos 2x and c1 cos 0 is 1 covered plus c2 into sin 0, so 0 plus x equal to 0, 0. So that means c1 is equal to 0. So therefore y is equal to c2 sin 2x plus x by 4, sir. Now substitute x equal to pi by 4, then you will get y value is equal to 1. So 1 is equal to c2 sin 2 into pi by 4 and sin pi by 2. Sin pi by 2 is equal to 1 plus x is equal to pi by 4 and pi by 4 by 4 and pi by 16. So that means c2 is equal to 1 minus pi by 16. So substitute into in this equation, then you will get y of x. So y of x is equal to c2 1 minus pi by 16 into sin 2x plus x by 4. So which is the required solution. So option A 1 minus pi by 4 sin 2x. So option is B is true, sir. Option B is true, sir. Okay. ఇంకా 2 క్వశ్చన్స్ ఉన్నాయి సార్, సో తర్వాత డిస్కస్ చేద్దాం, రేపు అప్లోడ్ చేస్తానండి. థ్యాంక్ యూ.